Alright guys, I finally have been able to print a prototype of our Project 1 for Beginning Fusion 360 course. This is the automatic refilling cup. So this is before I have dissolved the supports away. This is printed on a Stratasys, an old Stratasys machine. And you can see all the black material is support material, and that will dissolve away inside of a tank. And so we'll dissolve away all the supports, and then we'll be left with all of these fins inside and outside. And you can see it's got all kinds of support up through the center. So this is our model. It's more, I don't know if I would call it a cup now at this point. It's obviously like a jug. But yeah, I wanted to go ahead and update you guys and show you guys that I was able finally to have a printer that has a soluble support option capability that would allow me to actually be able to dissolve these supports away. So we're going to go ahead and throw this into the sodium hydroxide tank, dissolve away all the supports, and then we'll be left with our final model. We'll see how much weight it loses. Right now it's like 2 pounds. Right now it's like at least a couple pounds right now. And obviously this is a plastic model. Later on I'll make a metal model. But yeah, let's go ahead and dissolve away all the supports and see what we're left with and talk about it a little bit more. But so far, very impressed. This guy is perfect size to get your lips to seal around, so that was a great idea. So you can get a good seal across this, and we can use this as a functional kind, well, not necessarily functional, but aesthetic prototype, and then later on we can make the aluminum version of this with the fins, and then be able to put the Peltier cooler on the bottom. But we can fully assemble the prototype with it made out of plastic to visualize and make sure everything works. This guy is plus minus 4 is the tolerance usually that this guy will do, plus minus 4 thousandths, which is perfect for this kind of application. And also standard of what it would be on a mill, right? That's kind of standard tolerance on a mill, unless you're really pushing it and doing very specialty machine work. Alright, so I just want to show you guys before I dissolve all the supports away, which is again all the black material. The yellow material would be what is left. That's the material I had on hand. And actually it's very old material, so I wanted to knock that material out on this project and use the rest of it. Alright, so let's go ahead and throw it inside the soluble tank, and we'll get back to it in a couple hours. Alright guys, I finally have printed all the components for the Project 1, the final project in Beginning Fusion 360. So this is the automatic refilling cup, printed on a Stratasys 1200 ES 3D printer, and with ABS material and the soluble supports. You would have just saw the soluble supports. Now you see all of the soluble supports are gone, and so this is kind of the shape that it would be. You can see we have some stringiness. This is some very old material that came with the machine, so very old. And here we have the base, which is using two different materials. I ran out of the yellow and switched to a white. The white is actually way better than the yellow for whatever reason. And then here we have the Peltier cooler, which was like, I don't know, 30 millimeter by 30 by 3 or something. Anyways, so basically we have kind of a functioning prototype here to do everything that we would want, not functioning, but stand-in prototype. So what would happen is this guy would go here on the base, and then in here is our dovetail. Obviously I did not make it to a specific spec. There are websites that you go to with tables that'll tell you exactly how big to make the gland or the dovetail itself, the different heights, widths, and stuff like that for all the standard O-ring grooves, which again would go right here. This is where the O-ring would seal. Obviously on the plastic it wouldn't really seal here, because this is where it was touching the soluble supports. The sacrificial supports were right here. That's why it has this kind of grid-like texture. That's where the supports were grabbing onto it, so that's also here. So this would be planed flat and allow you to seal on that. Now of course, again, this is a plastic model, the final version would be made out of aluminum or stainless, right? Yeah. So anyways, basically when this is manufactured, you would have to go in there with a ball nose end mill and machine all of this out on the inside in order to get the performance that you want. And then of course this would go here, and then this would seal, and then there would be some sort of port that you would pull a vacuum on this guy, right? And again, this guy doesn't actually technically, I mean, I would prefer it to touch, and it's very, very close. This 3D printer is like plus or minus 5 on the, anywhere, well, plus or minus 4. I've been hitting plus or minus 4 thousandths tolerance on this guy, this printer, so I could feel that it's definitely close. I mean, I could bend it a little bit, and that's fine. Obviously, aluminum not going to bend as much, but we are pretty close, right, to having the actual, for it to be actually touching. So in actuality, we would have probably a little bit of tolerance here, or in a mill, we could get this very, very flat, and this very, very close to size. In this case, this is rough to size. Plus or minus 4 is kind of on the high side for sure. Plus or minus 4, but usually standard tolerance is plus minus 5, and then if you want tighter, you have to do a little bit more prep. So this is kind of within that plus or minus 5, because we're plus or minus 4. But thickness also is usually where I lose the most. I think I've had plus 10 on that, so that's plus minus 5. So I think most stuff is plus minus 4. But on height, it depends on how tall it is, but it's almost a percentage. Now, of course, I haven't tuned in this printer yet to do, to be a certain, you could set up the percentage of infill versus, the percentage of shrink compensation. And so I need to do that to get these, I can get these very, 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 very close. Anyways, so yeah, so here's the cube sitting in this guy, right, which is this Peltier cooler, and then this guy on top. So again, machining, come in there with a ball nose end mill, clean it all up on the inside, because it has this curve here, so you just go on with the ball nose end mill, and also you could smooth up the side here with the ball nose end mill over long periods of time. And then here, slitting saw, so come in with this guy, and then go in here and slitting saw around, and then you could do the fins. And the fins came out great. I think this would work pretty well. You'd have air be able to travel in here, and also because they are heatsink fins, we have increased our surface area of contact drastically instead of just having this surface exposed. So this is our heatsink to the room. And then inside, you can see beautiful inside. That is our heatsink to the cold side, which is going to absorb all of the water out of the air and condense it, and then fall into the bottom of the cup. Now, what I found is that this will carry a lot of volume. It's almost one of my large orange cups, an orange cup about this tall. About yay tall, just because of all the room inside of these grooves and also the height and all that kind of stuff. But what I did notice is that when I put some test pieces, I didn't drink the water, I spit the water out, mind you, but I couldn't get a really great seal with my lips around here, right? Mainly it's probably because of the rough surface, right? Because this is very, very old material. So that's why I thought that it would be great for this test, as it's not actually a functional something, it's not for a client, so this would be perfect. Anyways, then another thing, I think that I should definitely make this all the way in to touch, and again, that is so that when you're drinking, the water can actually get out of these rings, of these the heat sinks, so the water can travel up into your mouth. Right, so that when you don't have to tilt it so much that it jumps over the fins and splashes you right in the face. Alright, so overall, really, really good, very happy with it. So I think that this is definitely doable, and this is something that I could give to, with 3D printing, I could give it to my machinist if he wants to visualize what this thing looks like. He's like, oh, I can't really, again, he gets paid to be able to look at a model and build something off of a model, but this is a pretty complex part, as you can see. A lot of cutting with the slitting saw, a lot of going inside with the slitting saw and cutting all this out and cutting this out, very long end mill, going down to slot this out. So a lot of that is involved. So giving him a physical representation of the part is definitely going to save some time, and he can look at it. And even if he wants, he could come and saw this in half with a vertical bandsaw, and then have a cross section if he wants, and then be able to see all the parts. Right? Obviously, this is kind of nothing really to this. We have 6 holes in a dovetail O-ring. Dovetail a little bit harder. You can't actually make this like this in real life on aluminum because you need an opening point for the dovetail to go in and then travel around. So there would actually be a little opening somewhere in here so that you can actually be able to plunge the dovetail in and travel it around. And then of course this is a rough, this is minus all the electrical, because then you would need a port on here that is sealed where you have the electrical come out, right, to where you have the power come out. So obviously that's not here. So how are you going to get the power in, right? Okay. Well, I mean, you could always do, what is that? If you don't want to have a junction like that, you could always do wireless charging or something like that through the base, right? Have a pickup and then travel it through. Oh, it's metal. It's aluminum on the back, so that wouldn't work. Maybe if you change this no, you can't change the plastic because you need to be able to transmit heat. Yeah, so you'd have to have some sort of port here, some sort of pass-through bulkhead come through here, and be able to run your Peltier cooler, and then maybe even a 2 thermocouples or 2 thermoresistors here on the inside and outside, just to monitor how things are doing. Alright, so that's pretty much it, talking about the prototype. So now it's just to go into the process of making it for real, and obviously doing the electrical and the Arduino course, and seeing an actual functioning working unit. Alright, so pretty cool. I'm very, very impressed with this, with the printer, the new printer that I have. And if you want to learn about 3D printing, I have a beginning 3D printing introduction to 3D printing course, and then I'm working on an intermediate 3D printing course next year. So go ahead and check out on my courses, and you can find that. Alright, so that's pretty much it for these little prototypes here. Obviously super cool. You see it after with all the supports are gone. Still very, very heavy. But yeah, now I think it's more of a jug than a cup. Anyways, alright, so let's go ahead and move on.